Okay kids, we'll be going with this current electricity revision. So let me start with Ohm's law. So what does Ohm's law say? When you take some material and when you apply potential difference, then the current will be proportional to the potential difference, or when you plot V versus I graph, it must be straight line, right? So from there you'll be getting V equal to IR, where resistance will be defined by potential difference by current. So this is what we will be doing to define resistance, but this is Ohm's law, right? Now you can see this equation is linear. This equation is linear. This is Ohm's law. So from there we will be defining resistance, and this equation is linear. Whenever we have linear equations, we will be having some very good opportunities to superimpose and stuff. So we will see that also. Resistance will be given by rho L by A. Now rho will be changing with temperature. We will see the reasons later, or you must be knowing already. So resistivity will keep increasing with temperature. It is alpha is defined it as this way. So when you integrate it, when you assume alpha is constant, generally it is if it doesn't change with respect to temperature, you can take it out and you can integrate it. Finally you will be ending up with this result. But when alpha delta t is very small, which usually happens, alpha delta t is much less than 1, then you can approximate this to first two terms of e power x, right? So this is well known result. Now apart from this, the other stuff in the chapter are average current, instantaneous current, KCL. KCL is incoming charge equal to outgoing charge in steady state situation. That is conservation of charge and no accumulation of charge in steady state. KVL is total potential drop over a loop is 0, which is nothing but work done by electrostatic field, work done by electric field, whether it is this chapter or previous chapter, it will be conservative field only. So work done in a closed loop is 0. So power is the rate of work done, which you will be getting this way. And for a resistor, you can convert the same thing into ohmic resistor, ohmic conductor. You can do it this way or this way by using this part, right? Anyway, so let me go to the question. This is from NCERT. So they have given some observations, and they asked what you understood from here. Now when you calculate resistance value from all different things, all the information what you got, all the resistance values will be almost close to each other. So when you plot V versus I graph, it will be almost linear. So we know when it is almost linear, it is ohmic conductor, right? Now apart from that, if there is, now mostly we will be dealing with ohmic conductors only. So let me say this one. So when there is a resistor, when you apply potential difference AB, then the current I is flowing. So I can write A minus B equal to capital I into R. Now in some other situation, when I apply potential difference small a and B, then the current is small I. So I can write it this way. Now suppose if I apply potential difference A plus A and this potential is B plus B, then what is the potential difference? A plus A minus B plus B. Now I can write this one as capital A minus small b plus small a minus small b, right? Now what is this from the given information? It is capital I into R. This is small I into R. Let me say this is the new current in this situation, which I am representing with some other I. I can easily show you this current is nothing but summation of previous two currents. So what does that mean? If I have two different situations, if I superimpose, then currents will be superimposed and potentials will be superimposed, and this will happen. This is happening because of the linear nature of the equation. And this we'll be exploiting this in future anyway. So it's happening because of the linear nature. Because of the linear nature, you can superimpose two different figures. Then the potentials will be, you can add them like scalars, and currents also you need to add them, right? So again, V equal to IR. So when you modify it, you will be ending up with this equation. Anyway, we didn't see the reason till now. Generally, we will be doing this way. So J bar equal to sigma into E bar. We'll see the reason later, or you must be knowing. And these questions are from NCERT. This you can do by yourself. I just put it here so that if you won't be missing them in case if you have missed them earlier. Right, now going to this question. Now if this resistor is 2 ohm, this is 7 volt and this is 0 volt. And this resistor is 1 ohm, 2 ohm and 1 ohm. So what will be the current in each resistor? So what I will be doing here is I will be assuming this potential P as higher potential. And you can assume anyway, but it's like a algorithm. It will make the things much simpler. So I will be assuming P as higher potential. If P is higher potential, then the current will be outgoing, current will be outgoing, current will be outgoing. What will be the outgoing current? What will be the outgoing current here? P minus 7 by 2. What is the outgoing current here? P minus 0 by 1. What is the outgoing current here? P minus of minus 1 by 1. Now outgoing plus outgoing plus outgoing must be equal to incoming. What is the incoming? 0, because I assumed all the currents are outgoing. From here I can get the value of P. Once I got the value of P, I can substitute it back. Then I can see current will be flowing in this direction. Though I assumed this way, I can clearly see it is going to be in this direction. Now similarly I can find the current here, I can find the current here. And why I have shown this question is, generally I try to avoid KVL. If there is, most of the times you will be getting 3 resistors, and I can convert most of the circuits into this form, and I refer this as T-shaped form, right? I try to avoid using KVL. Now the next question is, there is 1 ohm, and this battery is 3 volt. There is resistanceless wire. This is resistanceless wire. Now the question is, how much current will be flowing in the resistanceless wire, and how the battery will feel about the resistors, that is, what is the equivalent resistance of the circuit. So what I will be doing here is, potential difference only matters for us, so I will be taking this potential as 0. If I take this potential as 0, this potential is going to be 3 volt, because that's what battery will do. Now if this is 0 volt, this is going to be 0 volt. What is the reason? V equal to I into R. Now V equal to I into R. On the left hand side, R is going to become 0. If R becomes 0, no matter what is I, if it is finite, then V is going to be 0. So the meaning is, if there is a resistanceless wire with finite current, that's what generally happens, finite current only will be flowing. So if there is a resistanceless wire, then potential difference across must be 0. But we can't say anything about the current. So okay, so there are many things here, so let me do one thing. Let me round off whatever I have used. This information is given, this information is given, this information is given, this information is given. Now what I am going to do, I have taken this as 0 volt, so I will be getting this as 3 volt, because that's what battery will do. Now if this is 0 volt, this is going to be 0 volt. What is the reason? Because it is resistanceless wire. In a resistanceless wire, if there is finite current, then potential difference will be 0, right? So if this is 0, that has to be 0. So similarly this one also has to be 0, and if this is 0, this is 0, 0, 0, 0, 0, 0, right? So if you don't want to see it like resistanceless wire, you can assume like resistance is very small, then the potential difference has to be very small, right? Now if this is 3 volt, then this is going to be 3 volt, and this is going to be 3 volt. If this is 3 volt, then this is going to be 3 volt. Now you can see this resistor is between 3 volt and 0 volt. So what will be the current? Current will be 3 ampere. Now similarly this resistor is between 3 volt and 0 volt. So the current is going to be 3 ampere. Now similarly this resistor is between 3 volt and 0 volt. So the current is going to be 3 ampere. Now you can apply KCL here. Outgoing current is 3 plus 3, 6. So incoming current must be 6. Now if this is 6, this must be 6. Now similarly, what is the incoming current here? 3. So outgoing current must be 6. Now at this point, what is the outgoing current? 3 plus 6, 9. So what must be the incoming current? 9, right? Now similarly here also I can see the incoming current is 6, incoming current is 3. So outgoing current must be 9, which must be matching with this value, right? So what is the battery voltage? Battery voltage is 3 volt. How much current it is giving? 9. So what will be the resistance it will be feeling? 3 by 9, 1 by 3. The other way of saying it is, these 3 will be in parallel, because you can see that this is between potential 3 and 0, 3 and 0, 3 and 0, right? Now going to the next question. The question says this one: an infinite ladder is constructed with 1 ohm and 2 ohm. So you need to find what is the equivalent resistance between A and B. So whenever there is infinity thing, what you need to see which pattern is repeating again and again. I have put some dotted lines here. If I see from here, whatever happens, the same thing will happen even if I see from here. So I am assuming that resistance as X. If this is X, if the resistance between A and B is X, then the resistance between these 2 points is also X. So what I can do is, I can see the same figure like 2 ways. One is by replacing this center part with X. By replacing this center part with X, I can see the same figure like this. Or by replacing this center part with X, I can see the same figure like this. But I know both figures must be equivalent to each other. Now, what is the equivalent resistance here? 2 into X by 2 plus X. These two are parallel, right? Plus that will be in series with 1. So equivalent resistance of this part is this much. But I know that equivalent resistance must be matching with this one, right? So that must be equal to X. So when you solve it, you will be getting, mathematically you will be getting 2 roots, but physically only one makes sense, right? And what they are asking, find the current that passes through 2 ohm also, which is closer. So that you can see here. X we got how much? X we got 2. So 2 and 2, 1. 1 and 1, 2. So 6 and 2 ohm. So 3 ampere, right? 3 ampere. So out of 3 ampere, it will split into 2 equal parts because these two are equal resistors. So 1.5 ampere, right? Anyway, so we will be going for the next question. So the next question says each element in the finite chain is of 1 ohm and current here is 1 ampere. So what you need to find, what is the potential difference across the input terminals? What is the equivalent resistance of the chain? How does the equivalent resistance change if 1 or 2 more resistors are added to it? Compare this result with equivalent resistance of infinite chain. So again, there are many things here. So whatever I will be doing, I will be rounding them off. Now they have given this current is 1 ampere and they have given this current is 1 ampere. Now what I am going to do is I am going to assume some battery here. That's what they are asking to find. They are asking to find what is this potential, right? So only potential difference matters for us. So I will be taking this potential as 0. Now those who are reading PDF, they can see the step numbers I have placed here. 1, 2, 2. So if this potential is 0, then every potential is going to be 0. The reason is resistanceless wire. Just now we have seen if some finite current flows in a resistanceless wire, then the potential difference has to be 0. So if this is 0, 0, 0, 0, 0. So I have done all this. Right. Now I'll start from here. Resistance is 1 ohm, current is 1 ampere. So potential difference is going to be 1 volt. So this potential is going to be 1 volt. If this is 0, then this is going to be 1 volt. Now if this current is 1 ampere, this current is 1 ampere by KCL. Now I can apply V equal to IR across this resistor. 1 into 1 potential difference must be 1. There is already 1, so this has to be 2. Now the potential difference across this one is 2. Resistance is 1, so current is going to be 2. Now outgoing current is 1 plus 2, 3. So incoming current must be 3. Now if incoming current is 3, then the potential difference is 3. So this potential has to be 5. If this potential is 5, then this current is going to be 5. Now if this current is 5, this current is 3, then this current is going to be 8. If this current is 8, then the potential difference has to be 8. There is already 5, so this has to be 13. If this is 13, then the current in this one is going to be 13. Now if the current here is 8 and 13, then this current is going to be 21. So if this current is 21, then the potential difference has to be 21. There is already 13, so this has to be 34. So what is the battery value? Battery EMF is 34 volt. And how much current it is giving? 21. So what will be the equivalent resistance? Equivalent resistance is 34 by 21, which is almost this much. Right. Now suppose if this ladder is not there, and if I put a battery of 13 volt, what would have happened? It will be giving 8 ampere. So what would have been the equivalent resistance from here to here? 13 by 8. Now suppose till this part it's not there, only this part is there. Then I will be keeping a battery of 5 volt, it will be giving current 3 amperes. So then the equivalent resistance is this much. Now if till here it's not there, if I keep a battery of 2 volt, then equivalent resistance will be 2 ohm, right? So you can see when I keep only one repetitive part, then I am getting 2. If I am giving 2 repetitive parts, I am getting 1.67, 3 repetitive parts 1.625, 4 repetitive parts it is 1.619. So you can see there is a drop and it went to almost, it is reducing very, very slowly. Now if there are infinite number of such repetitive patterns, or else if it is an infinite ladder, what will happen? You can go with the same way what we have done earlier. When you do that, you will be getting approximately 1.618. which is almost close to this one. So if you don't know how to solve infinite resistors question in exam, take 3-4 ladders and solve it, and the answer will be close to it if it is MCQ, right? Now this one we have already seen, superposition. Now this is one small example to understand. If there is 2 ohm, 2 ohm, 1 ohm, if the battery is 2 volt, then equivalent resistance is 2 and 2, 1 plus 1, 2. So battery is 2 volt, resistance is 2 ohm, so current is going to be 1 ampere. This 1 ampere will split into 2 equal parts, half and half. Now instead of 2 volt, if there is 4 volt, equivalent resistance is 2. So current is going to be 2 ampere, so it will be 1 ampere and 1 ampere. Now if I superimpose them, then the battery is going to be 6 volt, current is going to be 1 plus 2, 3, current here is going to be 1 plus half, current here is going to be 1 plus half, which you know how to solve, right? Equivalent resistance is 2, so the current is going to be 3 ampere, out of 3, 1.5, 1.5, right? So superposition works this way. You need to understand how to use superposition principle. Now this is a small example. Okay, you can pause and you can read the question. So what they are saying is this battery value, these two batteries, they are changing. All the resistors, they are keeping fixed, only these two values they are changing, and you need to find what is the current in this resistor in steady state. So inductor doesn't play any role, and we know it is a linear equation. It is a linear equation. So what I can do is I can predict the solution is going to be of this form. Current in this resistor will depend on E1 and E2 obviously, and it must be in linear form. So I am predicting the current equation must be of this form, A into E1 plus B into E2. Now they have given some other information in the question. When E is 1 and E1 is 1 and E2 is 1, current absorbed was 5. And when E1 is 2 and E2 is 1, current absorbed was 7. Now there are two variables, I got two equations, so I can solve them. So I will be getting A equal to 2 and B equal to 3. When I substitute it back, I will be getting the current equation as this way. Current is linearly dependent on E1 and E2 in this form. Now there are many other options. So they are asking what will happen when E1 equal to 3, E2 equal to 1, E1 equal to 1, E2 equal to 2, E1 equal to 1, E2 equal to 3, E1 equal to 4 and E2 equal to 1. That you can solve, right? So the only reason I have taken this question is you need to see linear equation. Now this you can take as practice anyway. That's from NCERT, right? Okay, now going to symmetry. What should be the value of R in the figure for which the current is going to be 0? Now those who know Wheatstone bridge, they will be saying it is Wheatstone bridge and the current is 0. But if at all you don't know the Wheatstone bridge, just because of symmetry, I can do one thing. What I am trying to do here is, there was some resistor here. I removed it and I was trying to see what is happening. So again, there are many things here. So what I will do is I will round off whatever I will be using. Those who are using the PDF, they can see the numbering in order, right? So this value is given in the question, 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 this value is given in the question. These values are given in the question. Now this equivalent resistance is 15, right? Okay, so anyway, battery is 6 volt. So I am taking this as 0 volt. If this is 0 volt, then this is going to be 6 volt, because that's what battery will be doing. If this is 0 volt, then this too will be 0 volt, because we have seen when there is a resistance-less wire, potential difference must be 0. If this is 6 volt, this has to be 6 volt, again resistance-less wire. Right? Now this total resistance is 15 and potential difference is 6. I mean, assuming that you know series and parallel, though I didn't teach it. Right? 15. Equivalent resistance is 15, potential difference is 6, so the current is going to be 0.4. Now similarly here also I can say the current is going to be 0.4. Now by using V equal to IR, potential difference, this potential is going to be 2 volt. Similarly this potential is going to be 2 volt. Now you can see both are at same potential. If both are at same potential, if you connect some resistor between them, what will happen? Nothing will happen, right? Current won't be flowing. So whether you connect resistor or you remove resistor, no current will be flowing, or else the other way of saying it is battery won't be knowing whether that resistor is there or not. So if you want to find equivalent resistance, if someone asks you to find the equivalent resistance of this one, what you can do? What does it mean equivalent resistance? How much battery will be feeling? We have already concluded battery doesn't feel this. Whether it's there or not, battery won't be feeling anything. So what does that mean? You can remove this and you can find the equivalent resistance. So what is going to be the equivalent resistance? 15 and 15 in parallel, so 7.5, right? Now there is other way of showing the current in it is going to be 0, the same question. Now but what I have taken here, I don't know what colors you will be seeing, but I have taken here as green color and this as blue color. There are many things here. This I will say later what I have done there. Now I am drawing some other figure here. The only difference between these two figures is I am rotating this figure. Now this part is green and this part is blue, so I am rotating it. If I rotate it by 180 degrees, I will be getting this figure. But I know by rotating the figure, I am not changing anything in the circuit. So currents must be remaining same. So what I am doing is I am assuming current in this one is A. Current in this one is A upwards. So if I rotate it, if I rotate it, what will happen? This blue color thing will go up this blue color thing will go up and green color thing will come down. Now this current which was going in the upward direction, now it will be coming downward, right? Now this is what will happen. If I rotate this figure by 180 degrees, this is what will happen. But these two are same figures. If I put everything in black color, you won't be finding any difference between these two figures. So the meaning is, if the current here is in this direction, the current here also must be in that direction. How can current go downwards and upwards? The only way it can happen is when the current is 0. So that's other way of concluding, but it's not, I mean, you can't, yeah, that's not so easy to see. Now there is other thing here. I have done it by the other way. This is what generally I will be doing. There are lot many things here, just follow what I will be saying. This is given in the question. These values are given in the question. Right, now I have drawn one more figure here. What is that figure? I rotated this and I have drawn it. Right, this is green color, this is blue color. When I rotate it, this will become green color, this will become blue color. Right, now I am putting both of them here. Now what is the first thing? First thing is, I will be assuming the current in this one is, or current in this one is A. So I will be assuming current in this one is A. This is what I assumed, that's first step. So if I assume current in this one is A, if I rotate it also, current must not change, right? Current in the green one is A. So current in the green one has to be A. I assumed this as A, from there I concluded this one also must be A. Now if this is A, if I put every figure in, both figures in black color, I won't be feeling any difference between these two figures. The meaning is, if the current in this one is A, then the current in this one also has to be A. Right? Now, yes. Okay, I think I didn't put one more figure here. Okay, fine. I think that's fine. So similarly, I assumed the current in this one is B. I assumed current in this one is B. If the current in this one is B, by rotating the figure by 180 degrees, current in this one has to be B. If the current in this one is B, then the current in this one has to be B, because they are essentially same circuits, right? Now, what is the outgoing current? A and A, 2A. So what must be the incoming current? 2A. 2A, right? So 2A, 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 2A. Now, what is the incoming current here? B and B. What is the outgoing current? 2A. So 2B equal to 2A I can say, or I can say B is equal to A. B is equal to A. So what is the incoming current for this point? A. What is the outgoing current? A. What is the incoming current for this point? A. Outgoing current is A. So what I can say? No current will be flowing through this resistor, because already incoming current is equal to outgoing current. So what does it mean by no current is flowing through this resistor? These two potentials must be same. So if no current is flowing, what I can do? I can remove it, right? So this is what I will be employing in further questions. Now again the same thing, you need to find the current, or you can find the equivalent resistance first. All you need to do is, you have to understand why there won't be any current in 50 ohm. If there is no current in 50 ohm, battery won't be feeling any difference whether you keep them or you remove them, right? So what is the first way we did? We removed them and we found the potential difference. If the potential difference is going to be same, even if you keep it, it doesn't make any difference, right? So again, what values are given? This value is given, this value is given, this value is given. These values are already given in the question. I removed this resistor and I removed this resistor. Now I'll be assuming this as 0 volt. So this is going to be 6 volt. If this is 0 volt, these two will be 0 volts because it is resistance-less wire. If this is 6 volt, then these two will be 6 volt because it is resistance-less wire. Now what is the potential difference? Potential difference is 6, and what is the equivalent resistance? 10, 10, 10, 30. So current will be 0.2 ampere. 0.2 ampere. 0.2 ampere. Similarly, I can say current here has to be 0.2, 0.2, 0.2. Then I can find what is the potential difference. It will turn out to be 2 volt. Similarly, this potential is going to be 2 volt. Similarly, this potential is going to be 4 volt, 4 volt. Now you can see these two are at same potential 2. These two are at same potential 4. If you keep some resistor also, no current will be flowing. If you keep some resistor here also, no current will be flowing. So whether you keep a resistor or remove a resistor, battery won't be knowing it. So how much battery will be feeling? 30 and 30 in parallel, which is 15 ohm, right? So even if you keep them, no current will be flowing, so battery won't be feeling any difference even if you remove them. Now the other way, the other explanation which we have seen. Now yes, so this is the first thing I assumed, and this is the First thing I assumed, current in this one is A assumed, current in this one is B I assumed. So if I rotate this figure by 180 degrees, what will happen? Blue color will go up and green color will come down, and current I'll be feeling like it is going in the downward direction, right? Now if I put everything in black color, you won't be knowing any difference between these two figures. The meaning is if the current here is A and B, then the current here also has to be A and B. Now, how can this happen? The only way it can happen is when no current is flowing. So you can remove those two resistors to find the equivalent resistance. Now, this is the general thing what I will be following. There are three figures here. The difference between these two figures is the battery. This is positive terminal is this side. Here the positive terminal is this side. The difference between these two figures is when I rotate this one by 180 degrees, I will be getting this figure. So this from here, if I rotate by 180 degrees, I will be getting this one. If I invert the battery, then I will be getting this figure. The other way of saying it is, you can see this one like a mirror image of this part. So if I look for this figure, if I look from this side, or for this figure if I look from this side, it looks same. So whatever happens for this figure from this side must happen the same way for this figure from this side. Anyway, so I'll be going with my steps other than the values given. What are the values given? These values are given. I'm not going to stress on them. Okay, I'm going to assume this current is A. If I assume this current is A, by rotating it by 180 degrees, this current is going to be A. Now these two are essentially the same figures, so if the current here is A, then the current here also has to be A. If you want to see why this current is A, assume these two are in fully black color, then you can understand. If the current here is A, then the current here has to be A. Now what I understood, if I look for this figure from this side or for this figure from this side, it must look same. So what is the current? A and A. So if I look from this side, it must be A and A. Now we know one thing, if there is a resistor, if I apply 2 volt here and 0 volt here, let me say the resistance is 1 ohm. So the current is going to be 2 ampere in this direction. What will happen if I invert the voltages? If I keep 2 volt here and 0 volt here, then the current is going to be same value but in the opposite direction. So that's the same thing will happen if I invert the battery. What will happen? These currents will get inverted. So if I invert the battery, the figure will look like this. So what I can do, I can invert the battery and I can invert the currents and I can put them here. So this is going to be my next step. I'm going to put the currents here. Now the resistance is 10 ohm and current is A. So this potential is going to be, if this potential is 0, then this potential is going to be 10A. So then this potential is also going to be 10A. So no current will be flowing. Now similarly, I can show this potential will be 20A. This potential will be 20A. No current will be flowing, right? So now what are things you need to see? You need to see the rotation and mirror image thing, right? Okay, now the next question is find the equivalent resistance between points A and B for these two figures. So I'll be drawing these. I'll be looking at the first one. So what is the difference between these two figures? It's the battery. Positive terminal. What is the difference between these two figures? I rotated that green one and blue one. I interchanged them. Still the figure looks same, right? So now what is the first thing? This is the first thing I'm going to assume. This current is A. If this current is A, even if I rotate it, this current has to be A. If this current is A, then this current has to be A, because they are the same circuits. Now if I look from this side or if I look from this side, it must look same. So these currents are going to be A and A. Now I assumed this as B, so this is going to be B. I assumed this as B, so this is going to be B. Now what will happen? If I invert the battery, then the currents will get inverted, right? So if I invert the battery, it looks the first way. So I will be inverting the battery and I will be seeing this one. So I can invert the currents and I can put them here. So from next time I won't be drawing two figures. I will be saying like if this is A and B, then this is going to be A and B. You need to understand. From here I will be getting it. Now you can look at this junction. Incoming current is A, outgoing current is A. You can look at this junction. Incoming current is A, outgoing current is A. So what will the current through this one? No current will be flowing through this resistor. The other way of saying it is, if no current is flowing through this resistor, these two must be at same potential. Some people may be saying like parallel axis symmetry, perpendicular axis symmetry, but all comes from here only one symmetry, right? So now if you want to find the equivalent resistance, what you can do, you can remove this. So 2R in parallel, so you will be getting R and R by 2, right? Now the next question, you need to find the equivalent resistance of this thing. So again I will be drawing the three figures. What are the three figures? If I rotate this by 180 degrees, I will be getting this figure. If I invert the battery, I will be getting this figure, right? So if I look from this side or if I look from this side, both must look same. Now what is the first thing? I will be assuming this current as A. If this current is A, if I rotate it 180 degrees, then this current has to be A. If this current is A, then this current has to be A, because essentially they are the same circuits. You can understand it when you see it in total black color, right? Now if I look from this side or if I look from this side, it must be same, right? So these two currents are going to be A and A. Now if A is splitting into B and C, if A is splitting into B and C, then this A also will split into B and C, right? That you can understand from here. If this A is splitting into B and C, when I rotate it, that this A will be splitting into B and C. Now these two are essentially the same figure. So if this is B and C, then this is going to be B and C. Now if I look from this side or if I look from this side, it must look same. So this one also will split into B and C. B and C. This one also will split into B and C. Now if I invert the battery, what will happen? Currents will get inverted. So what I can draw here, if I invert the battery, I will be getting this figure. I can invert the currents and I can draw here. So this current I am inverting and I am drawing here. This current I am inverting and I am drawing here. These two, okay, those currents also I am inverting and I am drawing here. Now what I can do is, here till now we have seen removing resistor. Now here I can't remove any resistor, but I can see, even if I remove this green connection, even if I remove this green connection, even if I make the connection like this, even if I make the connection like this, incoming current is equal to outgoing current C, incoming current is equal to outgoing current C. So even if I remove resistor, remove this connection, battery won't be feeling any difference, battery won't be feeling any difference. Now some people will do it, some people will do the other way also. If this potential is 0 and this potential is X, you can easily convince yourself like this potential has to be X, because current is same, resistance is same. So this potential and this potential has to be same. These two will be same potential. Now similarly these two will be same potential. So once you can understand these two will be same potential, these two will be same potential, what you will be doing, you can join these two, right? You can join and you will be saying it is parallel axis symmetry. Again everything is same, perpendicular axis symmetry or parallel axis symmetry, it's the same thing. You will be saying some perpendicular axis symmetry and you can remove the connection. Parallel axis symmetry, these two will be at same potential. Everything you can see once you put the currents, right? So what will be the equivalent resistance? Here we got R by 2. Here what we got? Here we understood we can remove this connection. So R and R, 2R and R, 2R by 3, right? So instead of this entire thing, I can put 2R by 3. This is R, this is R. Now this is R and R, which is 2R, and this is R, 2R by 3 and R. So when you find the equivalent resistance, you will be getting 4R by 5, right? Now there is this cube question. Cube question you must have learnt in class anyway. So you need to find the equivalent resistance between all the things like A and F and A and G and A and D. I will be going in sequence. So the first one is between this point and this point, which is body diagonal, right? Body diagonal. Now if battery is giving current 3A, I have taken 3A. Now it is split into 3 equal parts, because that you need to understand, or you might have been taught in the class. So these 3 parts will be equivalent to each other in this particular case, that you can rotate and you can see anyway. So you need to understand those 3 will be equivalent to each other. So if this current is A, this current will be A, this current will be A. Now I have already said I won't be drawing one more figure like mirror image. If this is A, then this is going to be A. Now these 2 parts will be similar to each other, so it will split into A by 2, 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 A by 2. Now you can write loop equation and you can find equivalent resistance, everything. That I am not much bothered about. And in fact you can even find the potentials. Now I can clearly say these 3 resistors are behaving equivalent to each other. So this potential will be same. Now similarly these 3 resistors are behaving equivalent to each other. This potential will be same. Now if these 3 potentials are same, what I can do, I can club them, right? If these 3 potentials are same, I can club them, right? That way also you can find the equivalent resistance. Finally it boils down to the same thing, symmetry, right? In fact, I can find the values of potentials also. I have just put it here. If this potential is V and this is 0, then this is going to be 2V by 5, this is going to be 3V by 5. Now the next question, don't bother about this 30 and 90. When I solved for the first time, I think the difference was given 30 and 90. Anyway, so I have taken a battery of 60 volt here. Now if this current is A, then this current is going to be A because these two paths are equivalent to each other. If this is A, but this is some other path, different path, so I am assuming this current is B. Now if this is A, this is B, then this will be A and B. Now you can see here, incoming current is A, outgoing current is A. So there won't be any current in this resistor. Now, incoming current is A, outgoing current is A, so there won't be any current in this resistor. If there is no current in this resistor, I can easily conclude these two will be at same potential. Anyway, I am not going to use it much. So I am removing these two resistors because no current will be flowing through it. Then it looks like this. Then you can see easily. These two are in series, so 2R and 2R parallel, R will be getting R and R in series, so you will be getting 3R. Now this is 2R and 2R, so you will be getting R. 3R and R parallel, 3R by 4 you will be getting, right? Anyway, you can see the splitting of current also. This B will be splitting into two equal parts. Anyway, that doesn't matter much. And in fact, I have shown here these two will be at same potential. These two will be at same potential. Everything you can conclude. Now, I think it's the same thing. I even found what is the value of potential here. That you can do by yourself if you want. Now going to the next question, equivalent resistance between these 2 points. Whenever they ask equivalent resistance between 2 points, you need to connect some imaginary battery. That's what I have done. There are two equivalent paths. So if this current is A, this current will be A. And I assumed this current as B. So this is A and B. This B is splitting, A is splitting into two parts, C and D. So this A also will split into C and D. Right? So this A will be C and D, this A will be C and D. Now this is D, this is D, this is 2D. So in this particular question, you can't remove any resistor, but you can say these two will be at one potential and these two will be at other potential. So you can redraw the figure by joining them and you can find the equivalent resistance, or you can use loop equations and you can find the equivalent resistance. I'm not much bothered about it. I have put it here. These two potentials will be Y. These two potentials will be X. Right. So anyway, that you must be knowing. You must have done it in the class. Now I will be solving it in the slightly other way. Forget about this 7I by 12. Okay, so if I join a battery, if battery is giving a current I, then it must look like this for me, right? Battery will be giving a current I, battery will be taking a current I. This is how it must look for me. So what I am doing is, I know superposition principle. So what I am going to do is, I am going to superimpose two figures such that I will be getting this figure. I will be getting this figure. So what I am going to do here is, I am going to take these two figures. Okay, first of all, let me see. I am going to give 7I by 8 current here, 7I by 8 current here, and I will be taking I by 8, 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 I by 8 from the remaining 7 corners. Totally there are 8 corners, so I am giving 7I by 8 and I am taking I by 8, I by 8, I by 8, I by 8, I by 8. So whatever incoming is equal to outgoing, that I am managing. Right? Now by symmetry, now these three paths are equivalent to each other, so I can conclude out of this it will split into three equal parts, 7I by 24, 7I by 24, 7I by 24. But I can't find the currents in the other resistors. Please note that. Now similarly, what I will be doing is, I will be taking current 7I by 8 from here and I will be giving I by 8, I by 8, I by 8 from the other corners. Now again I can conclude this will be 7I by 24, 7I by 24, 7I by 24, but I can't find the current in the other resistors. Now what will happen if I superimpose these two? If I put one figure on the other figure, what I will be getting? Current here is 7I by 8 plus I by 8, which is I. Current here is 7I by 8 plus I by 8, which is I. This current 0, this 0, everything will be 0. Only this one is I, this one is I. So when I superimpose these two figures, I will be getting this figure. I will be getting this figure where this current is I, this current is I. Right? Now if I want to find the current in this one, if I superimpose these two figures, what will be the current? 7I by 24, 7I by 24, which will be 7I by 12. So I will be getting the current here as 7I by 12. Then I can write loop equation V equal to IR. Now V by current given by the battery will give us equivalent resistance, right? So 7R by 12, 7R by 12. So what I did here, I used superposition principle. Now we are going to extend it. All the elements in the infinite grid are shown. So what is the equivalent resistance between two neighboring points? Now what we are going to do, we are going to do the same thing. Previously what I did, I gave 7I by 8 and I have taken I by 8, I by 8, I by 8. Now what I am going to do here is, I am going to give current I, and I am going to take equal current from every other part, which is I by number of extra corners, right? Previously there were how many corners? Previously there were 7 extra corners. Now there are infinite extra corners. So I was taking total current by 7 out. I was giving 7I by 8, so I was taking 1 by 7th of that. So here I am giving I need to take 1 by infinity of that. So that is very small current, 0, right? So I will be giving I and I will be taking very small current from other nodes, right? Which is almost 0. Now, but I don't know about the currents in the remaining part, but I can clearly say this is I by 4, I by 4, I by 4, I by 4 from symmetry. Now similarly, I am going to take the next point and I am going to take the current from there. If I take current I and if I supply very small current through every node, then I can clearly say this has to be I by 4, I by 4, I by 4, which is same as Q, right? So when I superimpose these two figures, what I will be getting? I will be getting incoming current is I, outgoing current is I, and this current is going to be I by 4 plus I by 4. That you can see here, right? So this one, I by 4 plus I by 4, right? So when there is a pattern here, obviously I didn't draw it. So when I write loop equation, V minus I by R, I by 2 into R equal to 0. So I need to find V by I to find the equivalent resistance, which is R by 2. Now the same reasoning you can apply for any other infinite sheet also. So here one current will split into I by 6, I by 6, I by 6. The other current will split into I by 6. So when you superimpose, you will be getting I by 3. When you write the loop equation, you will be getting the resistance as R by 3. Now you can see the next question. A plane divides the space into two halves. One half is filled with, let me say this is the plane. So that side half is filled with homogeneous conducting medium. And okay, so what you are going to do, you are going to measure the potential difference across these 2 points. What you need to find? You need to find the resistivity of the homogeneous medium using this data. You are sending some current I naught from here and you are taking I naught from here. So what I will be doing here is, again I will be using superposition principle. If I send current I here, what will happen? If I send current I into the board, it will be spreading, because that is infinite space, right? It will be spreading in hemispherical form. If it was full, then it would have spread in spherical form, but medium is only in that side, so it will be spreading in hemispherical form. So what I can do is, I can say current density at any position R, at any distance R, is I by 2 pi R square. If it was full medium, it is I by 4 pi R square. So J equal to sigma E I am going to use. So J is I by 2 pi R square because current given is I, right? So from here, electric field at a distance R, is this much. Now if I know the electric field at a distance R, if it is spreading in terms of spheres. So if I know the electric field at a distance R, if I want to find the potential difference between these 2 points or these 2 points, I can find. But potential difference between these 2 points is not reliable to find, because the size and stuff matters if you want to find the potential here. But anyway, we can find the potential difference between these 2 points. That's what we are going to do. How to find the potential difference between these 2 points? E bar dot dr bar. I am taking the magnitude only, because I know current will flow from higher potential to lower potential. So the more nearer it is, the more higher potential it is here, right? So when I do that integration, I will be getting the potential difference is going to be this much. Now in which case, when I am sending the current through A. Now similarly, I will be going to do the same thing when I am taking the current through B. When I am going to take the current through B, again I can clearly see current will flow like this. So D will be at higher potential, C will be at lower potential. The difference is going to be the same value. If you want, you can check. Now what will happen if I superimpose these two? If I send current and if I take current, what will happen to these two potential differences? In the first case and in the second case, you got something, so it will be add up, right? So when you add the potential differences, you will be getting what? 2 times of whatever you got, right? Yes. So this value you are going to measure using voltmeter, right? So from here you want to find the rho value. So you can find the resistivity value, and yeah, I think this is how you will be finding resistivities of some materials, right? Now the next question is Wheatstone bridge. I think you must be knowing the condition. What must be the relation between these 4 resistors so that no current will be passing through this one? So for that, what I will be doing is, I'll be removing that resistor and I'll be making sure that these two potentials will be same. When I do that, I'll be getting that condition R1 into R4 equal to R2 into R3. I remember it this way, R1 into R4 equal to R2 into R3, or you can remember the NCERT way, whatever. Now again, you can do this question by yourself. The only reason I have put the question is about point C. If the student uses large values of R2 and R1, currents through the arms will be feeble, so this will make things difficult, because if the current is very small, then if the currents in this resistor and this resistor is very small, then the current passing through the galvanometer is obviously small. So if the current flowing in the galvanometer is very small, then whether small deflection or zero deflection, you won't be able to find the difference. So what's the better option you have? Make sure they are not going to be very large. Now again, this one also you can read by yourself, that's from NCERT only, right? Okay. So what are the advantages of null point? No current will be flowing through the galvanometer, so we don't have to measure anything using device. Now this is meter bridge. What we will do in meter bridge, there is a wire here, you will be putting one known resistance and this is some unknown resistance. You will be moving the galvanometer jockey till it shows zero deflection. Now you can see Wheatstone bridge, this into this equal to this into this, right? So 6 into rho into, if you want to convert it into meters, you can convert rho into 0.2 by A equal to R into rho into 0.3 by A. So from here I will be getting R equal to 4. So what will meter bridge do? Using meter bridge we can find the resistance of unknown resistor by using one known resistor value, right? Now there is this question about option C. Anyway, you can pause and you can read the question. I will be going to the crux anyway. So what I am doing here is, I know I am going to take some 3 ohm unknown I am going to fix this 3 ohm and I am going to see what will happen if I put 1 ohm, 2 ohm, 3 ohm. So ideally it has to read 25 centimeter, 75, 40, 60, 50, 50. That you can manage by yourself. Now what I am going to do here is, though I know this is 3 ohm, I am going to calculate it assuming that it's unknown. So when I put 1 ohm, 2 ohm, 3 ohm, generally it has to show 25, 75, 40, 60 and 50, 50. So let me assume I made some error, or because of the device I calculated that length as 24 centimeter. This is 39, I have measured 49. So I assumed this length was measured 1 centimeter less because of any error. Now when I calculate the x value, it is going to be 3.17. This is 3.13. This is 3.12. So you can see actual value of x is 3, but there is a error here, there is error here, there is error here, but out of these 3 the error is small here. In fact, I can show you the error is going to be small when it is at almost at the midpoint. That you can see here. If this length is L, this is 1 minus L, x into L equal to R into 1 minus L. I mean rho by A will be getting cancelled. So from here when I found dx by x, I got this one. This one will be minimum when L equal to half. When L equal to half, the meaning is midpoint. So if you want to make the error less, what's the better option you have? From this information we can conclude the given the unknown resistor is almost close to 3 ohm. So it's always better to use the other resistor as 3 ohm, right? Like we did here. Now again, this is up to you. So potentiometer, anyway I didn't take it yet, but you can say the same thing in meter bridge. Meter bridge NCERT figure will look like this. These are metallic strips. Why we will be using metallic strips? Because in meter bridge we will be saying only this has resistance, right? We will be saying this doesn't have any resistance. So how we can do that? By taking metallic strips, we can say like those resistors will be very small and it will behave like ideal meter bridge, right? Now potentiometer figure, I mean that you can manage. Now voltmeter. So if there is a circuit like this, you can find the current is 3 ampere and potential difference is 18 volt. But if I want to measure this, what I need to do, I need to keep some device which is called as voltmeter. Let me say voltmeter has 6 ohm resistor. Then what will happen? Equivalent resistance is 6 and 6, 3 and 6, 9. So current is going to be 4 ampere and this potential difference is 24, this is 12. I am trying to measure 18 volt, but I am measuring 12 volt. So what is the problem? Because of the resistance of the voltmeter, circuit is going to change. Now if I want to design some ideal voltmeter, what must be its resistance? Let me see. Let me say the resistance is R, and what I need to do, I need to make sure it must not change the first figure. So the meaning is this equivalent resistance must be same as this one. So 6 equal to 6 into R by 6 plus R. So when I solve it, I will be getting the resistance value as infinity. So ideal voltmeter must have infinite resistance. How you can visualize it? So no current must flow through voltmeter, then it will behave like the same thing as first figure. So if it is infinite resistance, it will behave like open circuit. If it behaves like open circuit, the current flowing through this one will flow through only this one, which will behave like initial circuit. So ideal voltmeter must behave like open circuit. Now similarly, if I want to measure the current here, it is going to be 3 ampere. But if I want to measure, I need to put some device. So I am putting ammeter whose resistance is 6 ohm. Then the current is going to be 2 ampere. I thought of measuring 3 ampere, but I am able to measure 2 ampere. Why is that happening? Because ammeter is increasing the resistance of the circuit. So if I want to see what is the ideal ammeter's resistance, this circuit must behave same as initial circuit. So this 6 must behave like 6 plus R. So R is equal to 0. So ammeter, ideal ammeter resistance must be 0. The other way of visualizing it is ammeter must not oppose anything. So it must behave like a short circuit, right? Now anyway, you people must be knowing it. So if two resistors are in series, then equivalent resistance is R1 plus R2. From here I can conclude equivalent resistance is greater than individual values. If there are parallel, then R equal to R1 R2 by R1 plus R2. I can easily conclude equivalent resistance is less than both the resistors. Now we will be exploiting it here. Ammeter. Now generally we will be having galvanometer, which will be showing deflection for even small currents, but it will allow only small currents. So if you want to design ammeter which wants to measure more currents, then we need to do some modifications. Similarly, if you want to make some voltmeter, we need to do some modifications for galvanometer. Now what we have seen, ideal ammeter's resistance must be very small, right? So how we can do that? By connecting in series or by connecting in parallel? By connecting in parallel. So what we are doing, we are going to take some galvanometer, we are going to connect something in parallel so that the equivalent resistance will become less. At the same time, the current will be splitting into two parts, right? So for ideal ammeter, the resistance has to be 0. For that, shunt resistance has to be 0. Now similarly, voltmeter, you will be designing by connect them in series, because equivalent resistance you have to make more. And what is the, for ideal voltmeter, how much resistance you need to connect? Very large, infinity. Right? Now there are some questions here. A voltmeter consists of 25 ohm coil and 575 ohms connected in series. The coil takes 10 milliampere for full scale deflection. So galvanometer will show full scale deflection for 10 milliampere small current. What is the maximum potential difference that can be measured across the voltmeter? So I into total resistance. So you will be getting 6 volt. So if you connect this one in series, which we have seen, if you want to make a voltmeter, you need to connect some very large resistance in series with galvanometer. Then you are able to measure 6 volt. If you don't connect this, then how much you will be able to measure? 250 millivolt. There is a big difference, right? Now ammeter. If you want to construct an ammeter which has to read 2 ampere, but galvanometer will show maximum deflection for 1 milliampere. So the meaning is, if you want to measure 2 ampere, if you are sending 2 ampere current, then that must be equivalent to 1 milliampere for the galvanometer, right? So out of 2 ampere, 1 milliampere will go here. So remaining will go into this resistance. These two are in parallel. So this current into this resistance must be equal to remaining current into the other resistance. So when you calculate, this resistance is going to be almost 1.25 into 10 power minus 2, which is small, which we already know. Shunt resistance must be small if you are converting galvanometer to ammeter, right? Now this is a combination of both the questions. Now what they are going to say is, galvanometer resistance is 50 and this resistance is 1.15k, which is very large, which we know, and it is going to measure 12 volts. So I into R equal to 12. From there I will be getting I equal to 1 by 100. 1 by 100. What does it mean by 1 by 100? Galvanometer will take a current of 1 by 100 for maximum deflection. Now I am going to use it in the next one. If I want to convert this one into ammeter, I already concluded galvanometer will take maximum current of 1 by 100 for the deflection. If you send more than that, there is a chance of spoiling it, right? So now what you need to do, if you want to measure 2 ampere, then you need to make sure 1 by 100 will be going into galvanometer so that it will show maximum deflection. If this is 1 by 100, then the remaining will be 2 minus 1 by 100. These two are in parallel. So I into R equal to I into R. From there we will be getting the value of resistance 0.251, which is small, which you already know. Now going to potentiometer, you need to understand how this works. You can find the current in this one, so you need to do that every time. Now I am going to take some values for easy understanding. I am going to take 11 volt 1 ohm and this length is 1 meter and resistance is 10 ohm. So equivalent resistance is 1 plus 10 11, so current is going to be 1 ampere. 1 ampere. Now I am going to take one more circuit here. Now you can find the current is 2 ampere. Now what I am doing is I am joining this one with this one. So if I join these two, then I can say both potentials must be same because it is resistanceless wire, right? Now here I am connecting galvanometer jockey and I started moving it so that it will show zero deflection. If the galvanometer is showing zero deflection, what I can say, these two potentials will be same because no current is flowing through this one. And I can even show if no current is flowing through this one, no current will be flowing through this one, which you must be knowing already. So if no current is flowing through this one, no current will flow through this one also. So the meaning is these two will behave like independent circuits. The only thing is this potential will be same as this potential will be same as this potential. So this potential difference will be same as this potential difference. Now for how much length it will show zero deflection? For this potential difference to be same as this potential difference, right? This potential difference is 2 volt. So for this one the potential difference has to be 2 volts. So I into rho L by A has to be 2 volts. So when you do that, I into rho L by A has to be 2 volt. Now rho into 100 by A is given as 10 ohm. So rho by A I can find here and I can substitute here. I will be getting it as 20 centimeter. Generally this is not what we will be doing. What we will be doing in general, we won't be knowing this circuit. We will be connecting it and we will be seeing when the galvanometer will show zero deflection. If the galvanometer will show zero deflection for this length of 20 centimeter, then that corresponding potential is going to be 2 volt, right? So if you can measure the length, then you can figure out what is the potential difference, right? So we are using potentiometer like voltmeter. We are trying to find the potential difference between these 2 points. But how? They are asking us to find the potential difference, but I am going to measure the length because measuring length is the only thing I can do. If you want to see, you can see here also. In meter bridge, what we used to do in meter bridge? Someone asked me to find the unknown resistance, but what I did, I measured this length because I am good at measuring length but not measuring resistance. But I know if I measure this length, I can be able to figure out this one, right? Now, yeah, I didn't say building on fire thing, but if someone knows about that, then you can relate it. Yes, so what we did here, we used potentiometer as voltmeter. But there is one more good thing here. There is no current flowing in this circuit from here to here, right? But what happened when we try to use voltmeter? When we try to use voltmeter, it used to change the circuit. But what is happening here? It is not changing the circuit. It is not making the current to flow from this circuit to this circuit. This one will call it as primary circuit. This one will be calling it as secondary circuit. So when we are connecting some voltmeter, then current used to flow in the voltmeter also. But in this case, current is not flowing. So better than voltmeter, potentiometer is much useful for us, right? If you want to measure the potential difference, but there are some drawbacks, that's secondary thing. And this is one meme what I will be putting immediately after potentiometer, because I wanted to convey potentiometer acts much better than voltmeter. Now potentiometer, we are trying to use it to find the EMF of unknown battery and internal resistance. Now the same circuit I am taking. Now I am joining some battery with unknown resistance and unknown EMF. It showed zero deflection when the length is 50 centimeter. This is the only thing what I can measure. So if this length is 50 centimeter, I can find the potential difference easily, which is going to be I into rho L by A, which is 5 volt. If this is 5 volt, then this potential difference has to be 5 volt. Let me say this is A. If this potential is A, then this potential has to be A because it's resistanceless wire. If this is B, then this has to be B because no current is flowing. If this is B, then this has to be B because no current is flowing. So this potential difference is E. This potential difference is 5. So E is equal to 5. This potential difference is E. This potential difference is 5. Right? So from there what I can conclude, I got EMF of unknown battery. My aim is to find EMF of unknown battery, but what I did, I measured length. Now similarly, if I want to find the unknown resistance, I am going to use that value 5. Now I am going to connect some known resistance in parallel. again I'll be seeing where that zero deflection will happen. Obviously it must happen for less length than earlier, that you can conclude by yourself. Earlier it happened at 50, now it happened at 25. If it is 25, then this potential difference is going to be 2.5. This potential difference is 2.5, then this has to be 2.5, this has to be 2.5. Now how to find this potential difference? Current in this one into resistance. Current in this one is I into resistance 1. So this potential difference is equal to this potential difference. How to find this potential difference? I into rho L by A. I is 1, rho by A is 1 by 10. So when you substitute, you will be getting R value as 1. What is this? Internal resistance. So what we did here, we found the EMF of unknown battery and internal resistance, right? Now to find the internal resistance, you don't have to actually find the EMF of the battery also. Anyway, from the questions you can see that, but that's the crux of the story. Now potentiometer to compare EMFs of two cells. So again, I into rho L by A equal to E1, I into rho L by A equal to E2. So E1 by E2, you can compare the EMFs of cells. For that, you don't even need any information about primary circuit. So sometimes you don't need much information about primary circuit, that you can see from questions. Right, again, this question is from NCERT, you can do it by yourself. The only reason I have put it here is, yeah, for this one you can do by yourself. Okay, what's the purpose of high resistance? What's the purpose of this high resistance? So that it won't spoil the galvanometer. Right, this is the reason I have put it, but anyway, that doesn't matter much. Now again, thick metallic strips will be of less resistance. Now maximum power transfer theorem. If maximum power has to be dissipated in this one, its resistance must be equal to this resistance, that you can find power in this one is going to be I square R. If it has to be maximum, first differential has to be 0, you will be getting R equal to R, which is maximum power transfer theorem. Now whenever maximum power transfer theorem comes, like it looks easy here, but if the circuit is complicated, it is going to be difficult. So I know this is going to be easy when the circuit looks like this. So though it's not in syllabus, still it's better to know Thevnin's theorem. What does Thevnin's theorem say? If there is some circuit and if you want to find some information in this one, you can replace all the remaining part of the circuit. If the remaining part of the circuit consists of resistors and sources, then you can replace all the remaining parts with a single voltage and single resistor. If you want to find some information in this one, let me call it as load. If I want to find something about load, and if the remaining part of the circuit consists of resistors and sources, then I can replace all those sources and resistors with a single resistor and single source. So that the 2 ohm is my load. So across the 2 ohm, I can connect one single source and one single resistor. How to find those two values, we will see. Now, if I look from this side, for this figure or for this figure, it must look same. So yeah, if the battery is shorted, if I look from here and if the battery is shorted, the entire thing must look same as the battery is shorted here, right? So the equivalent resistance across these 2 points must be same as the equivalent resistance across these 2 points. So what is the equivalent resistance here? 2 by 3. So this must be 2 by 3. If you want to find, this theorem is called as Thevnin's theorem, and that resistance is going to be called as Thevnin's resistance. If you want to find Thevnin's resistance, short circuit to the batteries and find the equivalent resistance across the load, which is 2 by 3. If I want to find equivalent Thevnin's voltage, what I need to do? Oh, how much potential difference I will be feeling now when I open it? It is 4 by 3. So here also, if I open, I need to feel the potential difference as 4 by 3. For that, this has to be 4 by 3. If I want to find Thevnin's voltage, open the load and find the potential difference across the load, right? So you can replace this entire remaining part of the circuit with a single resistor and single voltage source, which is called as Thevnin's voltage and Thevnin's resistance. How to find Thevnin's voltage? Open the load and find the potential difference. How to find Thevnin's resistance? Short circuit the battery and find the equivalent resistance across the load. Now you can see, I think you can calculate the current from here, which is 2 and 2, 1 ohm, 1 plus 1, 2. So current is going to be 1. Out of 1, half and half will be splitting, which you know. Now see whether the current is going to be half here or not in this one. Battery is 4 by 3, so equivalent resistance is this much, so current is going to be half, right? So if you want to find the current in this one, you can replace the remaining part with a single battery and single resistor, right? Now going to the next question. A current of 1 milliampere flows through a wire. Anyway, that doesn't matter much. Don't worry about the values, because you need to know some values to get the exact answer. Is made to pass through a piece of copper and piece of iron, identical cross section, welded end to end. So there are two wires like this, but this is made of one material, this is made of other material. Now you need to see how much charge will be accumulating here, which is not what to say. KCL, in KCL we will say like there is no accumulation of charge, but we are saying accumulation of charge happens here. Anyway, we will see that. So J equal to sigma E we know, and here current is same in steady state and area of cross section is same, so J is going to be same, and sigma is going to be different for two different materials, so E has to be different for two different materials. Now if I take some Gaussian surface, whether cylinder or cube or anything, then yeah, flux through the curved surface is going to be 0. If I take a cylinder, flux through this area is going to be electric field there into area, flux through this area is going to be electric field there into that area. Incoming flux, outgoing flux. So total flux equal to charge enclosed by epsilon naught. From here you can see charge enclosed is this much. So there is actually charge enclosed here, which is creating more electric field to make the steady state to happen. Now when will this charge get accumulated? Immediately after switching on the circuit. It will take very less time. Now, but whatever we learnt in the chapter is after steady state is achieved. Given KCL is defined, after steady state is achieved, and the charge is going to be very small, so you don't have to bother much. And in fact, not only, I mean, here as two materials are different, then the charge is getting accumulated. If two materials were equal, then it would have been 0. So that's what you can. That's what KCL says, right? In steady state, or if it is a same material conductor, so there won't be any junction, right? Because of the junction, charges are getting accumulated because they have to push with more force that side, right? Now, not only that, you can see whenever there are, you can read the explanation by yourself, that will be available. When there are bends, how come the current changes the direction? Now, suppose the current is because of positive charge movement. How the positive charge which was going in this direction, it will be going in this direction. How it is going to change the direction? For that to happen, there must be charges accumulated on the bends also. So not only near the junctions, near the bends on the surface, charges will get accumulated. But those will be very small. Charges will get accumulated so that everything will be working on steady current. Everything will be doing, everything will be supporting, everything will be doing something to support steady current. And the amount of charge is going to be very small anyway, that doesn't matter much. Now this is from NCERT. So if the current carrying wire is in the shape of a circle, then so who is that agent responsible for making the electrons change the direction or stuff? So which we have seen, it is electric field produced by the charges accumulated on the surface. Now similarly, going to the next one, at a junction there will be electric field. Now, right, whatever. So anyway, those two things you can do yourself from there. Now this is the derivation of or understanding Ohm's law. Till now Ohm's law is experimental thing, right? But we try to understand why that was working. Ohm's law is experimental result, but we try to understand how we understood it because of the drift of electrons. Now drift velocity is going to be something like this, and where tau is the relaxation time. Now, I equal to NEAVD, when you do the modification you will be getting J equal to sigma E. So resistivity is going to be m by Ne square tau. M is mass of electron, E is charge of electron, N is number of free electrons per unit volume, and tau is average relaxation time, that is average time between two successive collisions. Now when temperature increases, this number of free electrons are not going to change that much, because there will be already many number of free electrons, which you can see from NCERT example about the number, right? If you increase the temperature, they will change, but only by small amount. That doesn't matter if you add some or subtract some when they are really huge in number. But relaxation time is going to reduce. If relaxation time is going to reduce, resistivity is going to increase. So, right? Anyway, this derivation we have already seen. Now these are from NCERT. Anyway, the only reason I have put it here is to specify the importance of this one. Drift velocity is going to be millimeter per second, but thermal velocity is going to be 2 into 10 square. Thermal velocity is very large when compared to drift velocity. Drift velocity is going to be very small. and this is also from NCERT, you can try to understand that. Now again, this question is to specify drift velocity, to stress on the point drift velocity is very small. If the electron has to travel 3 meters using its drift velocity, then it will take 7.5 hours, which is very large. Now relaxation time, till now we said relaxation time depends on the temperature. Actually it depends on the electric field also, because relaxation time is the time gap between two successive collisions, right? So the more speed it goes with, the more frequently it will collide with. But what we have seen, because of electric field there will be only drift velocity will be only millimeters per second, so it won't be affecting much. But thermal velocity is of the order 10 square, right? Anyway, the next one you can do by yourself. If you want, you can refer NCERT. Now this question is from NCERT. Determine the currents in each branch. Now I'm just going to show you like the final option. When you don't know what to do, the final option is KVL. By KVL you can get answers for almost all the questions. Now the first thing what you need to do is, okay, there are many things here. Whatever I'll be saying, I'll be rounding them off. So you need to see loops, small loops. How many small loops are there? 3. So assume the currents either clockwise or anti-clockwise for better solving. So what I am going to do, I am going to assume currents as anti-clockwise. Current in this loop is A, current in this loop is B, current in this loop is C. If the current in this loop is, okay, if the current in this loop is A, I can say current here is A, current here is A, current here is A, but current here, okay, let me go with that later. So current here is going to be B, current here is going to be C, current here is going to be C. But what about the current here? According to this loop, current has to be A, according to this loop, current has to be B. So what is the net current? A minus B. Now similarly, according to this loop, current has to be A, according to this loop, current has to be C, so A minus C. Similarly, according to this one B, according to this one C, B minus C. Now after doing this, what I will be doing is, current will flow from higher potential to lower potential, so I will be putting the symbols so that I can use KVL nicely. And potential difference is I into R. So higher potential, current will be flowing from higher potential to lower potential, and the potential difference is I into R. Similarly, potential difference is I into R. Potential difference is I into R. Potential difference is I into R. Now, how many unknowns I assumed? 3. How many loops I can see? 3. So I will be writing 3 loop equations and I will be solving them. Now, these are the 3 loop equations. You can check by yourself. First equation, second equation, third equation. I just modified it. When you solve them, you will be getting A equal to this much, B equal to this much, C equal to that much, which will be matching with NCERT answer. Now there is other question which is again from NCERT. But these are bad values. Again I have done the same thing. A, B, C. There are 3 unknowns, 3 loops. So I will be writing 3 loop equations and I will be solving them. I will be getting the same answer as what NCERT will be getting, right? Now, okay, so this is the question, and in this question you need to find what is the current in the other resistors. Now how many loops you can see? You can see 2 loops like previously, right? So when I write loop equation, it doesn't matter whether I into R will come first or this one will come first. So even if I keep it here and if I keep the resistor here, still the loop equation will look same. So I know when the 2 loop equations look same, the result has to look same about currents, right? So what I can do, I can interchange these 2. When I interchange these 2, I will be getting this figure. If I interchange these 2, I will be getting this figure, because I know interchanging won't be affecting the currents because loop equations are not going to change. Now why I am doing that is, if I assume this as 0, this is going to be 7, this is going to be 0, 0, minus 1. Now I can see T-shaped figure because I am comfortable with solving T-shaped figure, so I am trying to convert it into this form. But I can't see it here because there is a problem. If this is 0 volt, I don't know how much is this. There is a problem. So yeah, I could have assumed this as x and this as x plus 1, but still that was a problem. So I interchange it so that I can see T shape. So interchanging is something what you can do in the figures to make it look more familiar. After that I will be solving for potential and I will be finding the current, which was, I think it's exactly the same question what I took in the very beginning. I just modified it and drawn this figure to explain the same thing. Now there is a next question here. This is 5 ohm. This resistance is 5 ohm, this resistance is 5 ohm, 10, 10, this resistance is 5. Now 5 into 5, this is 10 into 10. It is not Wheatstone bridge. But what I can see the symmetry. If this current is I5, then this current has to be I5 by mirror image thing. If this current is I10, then this current has to be I10. And then this current will be like I10 minus I5 or whatever it is, right? Now, I assumed this potential as 0. See, I have taken this as 100 volt because I have to find the equivalent resistance. I know equivalent resistance doesn't depend on the value, but I am taking this value because I know some round figure will give me good calculation. But even though it went bad calculation here, but at least it's better than taking 7, right? So if I assume this as 0, then this is going to be 0. If I assume, this is 100, I assume, so this is 100, 100, right? Now, this resistance is 5. This resistance is 5 and this current is I5. This resistance is 5 and this current is I5. So this potential difference and this potential difference must be same. I assume it as X. Potential difference is X. So this potential difference has to be X. So this has to be 100 minus X. 100 minus X. Now, the same thing, fine. Now, what I will be doing, I can see T shape here. So I will be writing the same formula for this T shape. Outgoing current must be equal to 0. From there I will be getting the value of X. So what I am doing is I am putting the value of X. So I will be getting 300 by 7, 400 by 7. So I will be getting the current here is 60 by 7, 40 by 7. Current here is 100 by 7. Battery of 100 volt is giving 100 by 7 current. So what will be the equivalent resistance? It will be feeling 7 ohm, which is much better than writing loop equations. I can get it much quickly, right? Writing 2 loop equations and solving them. I think this is, I mean, there is no thumb rule. There are different ways. You find your own way. Now this one also, I just put it there so that you can read the stuff from NCERT. This one also. Now you can read the question. The question goes like this. Resistance of conductive medium. A metallic sphere of radius A is surrounded by concentric thin metallic shell B, and the space between them is filled with between these two electrons is filled with homogeneous poor conductive medium of resistivity rho. Find the resistance between two electrodes. So if you want to find the resistance between these two, what you will be doing, you will be taking some element, you will be finding the resistance and you will be integrating. You will be getting this result, which you must have done in the class. Now suppose if B is much greater, like infinity, then what will happen? Resistance is going to be this much. That is, when there is only one conductor and the medium is spreaded throughout, then what will be the resistance? Rho by 4 pi A, right? Now, if there are two small spheres and the distance between them is large, you can read the question. Two identical metal balls of radius r and poorly conducting homogeneous medium. Find the resistance of the medium between the balls under the condition that the size between them is very large when compared to their size, right? So, if I connect a battery, then it kinds of behaves like a capacitor also, right? So let me say this charge is plus Q and this charge is minus Q. So then what I need to find? I need to find resistance. Resistance is potential difference applied across these two by the current, right? By the current. So what is the potential difference? This potential is kq by A, that potential is minus kq by A. So the difference is going to be 2 kq by A. Now I need to find the current. Now if I want to find the current, what I am doing is I am taking one Gaussian surface just outside this sphere. So if current is current density times 4 pi into that radius square, which is A square. Current density is sigma times of electric field. Electric field here will be because of majorly this charge only. That won't be contributing that much. So electric field I can write it as kq by A square, which after cancelling you will be getting this one. Now when you divide both of them, k is getting cancelled. I didn't bother much about the medium, but I have taken like some medium of epsilon, whatever, vacuum kind of. But still, even if you take some other medium also, that k is getting cancelled. So it is irrespective of what is the dielectric constant of the medium. So what you are getting? Rho by 2 pi A. For one sphere you got how much? Rho by 4 pi A. For two spheres how much you got? Rho by 2 pi A. So you can see them like kind of series, right? Yes. So going to capacitor, consider the situation. So when the capacitors are uncharged, find the charge on the capacitor C1 as a function of time. C1 as a function of time. I know if this charge is plus Q, this charge has to be minus Q. If this is minus Q, this has to be plus Q because these two are isolated. So charge on these two things are same. So while writing loop equation, what I can write? I can write this one. E minus Q by C1 equal to minus Q by C2 minus IR is equal to 0. So when I modify it, I will be getting this one. I am replacing this entire thing with 1 by C. The reason is I am familiar with this equation. This equation looks like this figure. For this figure, I know the solution is going to be this form. Now, solution is going to be this form. At t equal to 0, what is the charge? Charge is going to be 0. Okay, when t tends to infinity, what is the charge? C into E. So at t equal to 0, charge is 0. At t tends to infinity, charge is CE. So from here I can get the values of A and B, and when I substitute it back, I will be getting the charge equation as a function of time, right? I mean, you can do the integration also. I am just trying to avoid integration by seeing something what I already know. Now the next question. This is the next question. A capacitor of capacitance C is already having a charge Q. Now it is connected across some resistance, and you need to find what is the charge, right? So yes, across resistance and capacitance of equal thing. Now what will happen? This charge will start flowing till when it will keep flowing till this potential difference will be same as this potential difference. After that, current will stop flowing, right? So when will this potential difference will become equal to this potential difference? In this particular case, it is going to be easy when the charge on both the things are equal, right? So I am going to exploit that. I will be writing loop equation. It looks like this. When I modify it, it looks like this. Now this equation is familiar to what I know. So this equation, I am seeing it like this figure. So for this figure, I know the solution will be of this form. So what is the charge initially? Charge initially was given as Q. Charge finally is going to be how much? C into V, right? C by 2 into Q by C, which is Q by 2. Charge finally is going to be Q by 2. When I solve it, I will be getting A equal to this much, B equal to this much. When I substitute it back, I will be getting charge as a function of time. Now, yeah, time constant. What is the time constant here? It is RC by 2. It is not RC, right? So I am writing the equation. I am looking the equation into some particular well-known figure because I can use this as solution of the figure. I am going to do it one more time. So here a capacitor of capacitance C is given a charge Q. It is connected to ideal battery through a resistor. Find the charge on the capacitor as a function of time. So again, I will be writing the loop equation. This loop equation looks like this. So general solution is this one, right? Both are same. I don't have to do it. Now if the general solution is this way, at t equal to 0, charge is given as Q. When t tends to infinity, it will behave like open circuit. So charge is C into E. So when I substitute it, I will be getting A value, B value. When I substitute A value, B value back, I will be getting charge as a function of time, right? Now the next question. There is a capacitor like this, resistor. So I need to find charge as a function of time. So what I am going to do here is I am going to take two loop equations just for the sake of doing it. So I assume that the current in this one is capital I, small I, and yeah, this is positive charge. The rate at which this is accumulating is I. dq by dt is small I. So I will be writing loop equation for this one. I will be writing loop equation for this one. When I solve it, what I don't need I. I need this one and Q so that I can integrate. So when I eliminated capital I from these two equations, I got the equation like this. Now once I get the equation like this, I can visualize some figure like this. Once I can visualize some figure like this, I know it must be of this form where time constant is R into C by 2. Now at t equal to 0, what is the charge? 0. When t tends to infinity, charge is C by 2 into V. So from there I will be getting the value of A and B. When I substitute it back, I will be getting charge as a function of time. Charge as a function of time. But that's a mess because writing loop equation, I try to avoid KVL, I said, right? So we have seen something like Thevnin's theorem, near maximum power transfer theorem. Now I am going to exploit it again. So what I said, when there is load and apart from load, if the remaining things consist of only resistors and batteries, you can replace that entire thing with a single battery and single resistor. That's what I am going to do here. What does Thevnin's theorem say? If this is the load, if remaining part consists of only resistors and batteries, you can convert it into single voltage and single resistance. How to find that voltage? Open the load, find the voltage potential difference here. So if this potential is V, then this potential drop is V by 2, you can get that easily. So Thevnin's voltage is V by 2. If you want to find the equivalent resistance, short circuit the battery and find the equivalent resistance across this one. These two are going to be parallel, so equivalent resistance is going to be R by 2. So what you can do, instead of this entire thing in box, you can replace with a single battery and single resistor. That battery has to be V by 2 and that resistor has to be R by 2. Right, now this is a simple looking circuit and it must be of this form where time constant is R by 2 into C, right? For t equal to 0, charge is 0, and t tends to infinity, charge is c into v by 2. From there we will be getting the value of a and b. You can substitute it, and we will be getting charge as a function of time. Right? Now apart from that, there is a parallel plate capacitor. You need to find what is the value of R into C. When you do that, you will be getting epsilon rho k, which doesn't depend on the dimensions. Right? This is not only for parallel plate capacitor. You can see it much easier in a parallel plate capacitor. I can even show that for two random arbitrarily shaped conductors. Right? Resistance is V by I, capacitance is Q by C. So when I need Q by V, so when I need to multiply, I will be getting Q by I. If I want to find I, it is integral, closed integral j bar dot dA bar for closed surface, j equal to sigma E. So I can get it this one. Now charge is epsilon times of Q by epsilon naught is closed integral of E bar dot dA bar, right? That is Gauss law. But there will be some induced charge and stuff. So if I want to find this charge, I need to find what was the electric field without dielectric, right? So which will be old electric field without dielectric. Now old electric field is k times of new electric field, right? So I will be getting this one. When I do the division, I will be getting epsilon naught k rho. So this result is valid for any arbitrary shaped conductors, not only for parallel plate capacitor, but it's easy to get it for parallel plate capacitor. So you can get it for parallel plate capacitor, and you can trust it if you need to use it, right? Thank you.